This says advanced sorts part 1, because when I wrote this, I anticipated writing a part 2, but then I took a different direction and decided there were more important things to cover. So this part 1 is part 1 of 1. So the sorts that we just went over on the board are, comparatively at least, intuitive, which is wonderful. What do we know about intuitive things in computer science? We don't use them. What is intuitive to us is slow to a computer. So we have the trade-off. Intuitive and easy for us, slow for the computer. And computers dictate everything that we do. We don't get to do things that are intuitive. We have to do things that are fast. Since we've now covered recursion, and hopefully that is becoming more intuitive with more and more practice, we can use the power of recursion to improve on how we can sort. So we're going to introduce, starting with merge sort. Merge sort is a wonderful algorithm. This is probably my favorite sort, and fun fact, it is the sort that is used underneath the hood in Java when you call .sort on a collection. So let's say we have some array of random integers that's not sorted. The base case is that we know an array of size 1 is already sorted. That makes sense recursively, right? We have an array of size 1. We don't have any work to do left to sort that array. So let's, at least with our last few minutes, intuitively start to take a dive into this algorithm. So what are the steps that we need to do to sort an array recursively? We first are going to split the array in half. So instead of having one array, we're going to have 2 arrays, the first half and the second half. We're going to now recursively call merge sort on the left half and the right half. So as soon as we do this, we're just going to wait. After this waiting is done, the left half and the right half will magically be sorted. That magic is going to be the rest of what we talk about here. So we are waiting for that recursive call to come back. When it comes back, left is sorted and right is sorted. We then need to do what we just wrote on the board, merge the resulting sorted lists into a new, larger sorted list. The reason I threw that on the exam is that it helps make this more intuitive. You've thought about it before and seen it before. This is a subroutine of merge sort. So the way we're going to do it is we can now do this iteratively. I'm not forcing the merge to be recursive. The nature of merge sort is recursive, but the merge process itself does not need to be. We're going to place some pointers. One is at index 0 of each sorted array. That accounts for 2 of them. And 1 is going to be at the beginning of the merged sorted array. We then need to iterate. We're going to loop, comparing the values at the pointed indices. Whichever one is smaller is the exact opposite of what I just wrote on the board, starting with the larger and working with the larger. Whichever one is less, we're going to copy that over to the merged sorted array at the current index and bump up the counter for that array and only that array. Then you loop around and compare the 2 elements that are pointed to in the left half and the right half. You continue to do this until we've accounted for everything in both arrays. And then we have a merged sorted array. Any questions about how this works? Can people visualize this working at the multiple levels? The next thing I want to do is draw it out, but I don't think I can draw it out in 3 minutes. So I want to get the intuitive idea there, and then we're going to come back on Monday and make sure that we fully draw this out and understand it at a deep level. So unsorted array, left half, right half, wait for those to be sorted, merge them together into one sorted array. And that is one instance of the recursive call. Question?
When you say place 3D counting pointers, is that pretty much the same thing like on the queue, you have the front and the rear?
Yeah, they're really just, yeah, they're reference variable, they're index variables that represent where in the array something is pointing. So I like to think of them as reference variables or pointer variables, because that's what they would be in a language that supports pointers and pointer manipulations. Is that it's basically saying, here's what the next element in this array is that we care about. So it's just like a reference variable that says, you know, where is the student with this particular name? There.
So if you're writing it like a language that actually supports real pointers, like when you have the actual asterisks.
Yeah, you could, depends on how you want to store it. If you want to store it as a pointer that says the answer is at that memory address, then you can. You could also store an integer and say, based on the starting location of this array, now we can do some math to figure out where that is. Let's say we want index 3, and we can say, what is the address where this array starts? Add 3 times the size of whatever the variable type is that's stored in this array. Add 3 times that to the start of the array, and that gets you to the index or the memory address where it begins. Languages that support pointers, just about everything is done in terms of where something is stored at a memory address. And that's all happening underneath the hood here, but Java as a language doesn't really like you thinking or forcing you to think in that way or needing you to think in that way. So it kind of abstracts that, and everything is now just the index. Underneath the hood, the compiler is doing all of that work for you of converting that logic down into what memory address should I go retrieve information from. That's a great question, though. Has a nice deep answer to kind of language design. But yeah, so I guess we'll come back to this on Monday. I will actually get your assignments up so that you can get started on that. I will probably start out having it due on Wednesday, and I do not know if I will push that back yet, but we'll see how it goes. I think this one's going to be a little bit easier and less work. I don't know about easier, but it is less work. Yeah. You do have an assignment due tonight, though, so I have an office hour starting now. Choose like some assistance. And kind of remember to give me your exam before you leave. You can't